Chemistry is the study of matter and the changes it undergoes during chemical reactions. These changes include physical and chemical properties of substances, their composition, and energy content. Chemistry is useful as it helps you to solve real-life problems, as it is used in the development of pharmaceuticals for the treatment of diseases, in pest control, food preservation, as well as other household and industrial uses. Chemistry is often referred to as a central science because it joins together physics, mathematics, biology, medicine, earth, and the environmental sciences. Knowledge of the nature of chemicals and chemical processes provides insight to a variety of physical and biological phenomena, which provides an excellent basis for understanding the physical universe that we live in. Studying chemistry puts you in a position to choose from a wide variety of interesting and rewarding careers such as medicine, research and development, chemical engineering, forensics, food chemistry, pharmacology, teaching, toxicology, and medical or chemical technologies. The advances made by applying the principles of chemistry to our lives has brought us to a civilized vantage point where many persons can now overcome chronic illnesses and sometimes escape death. Chemistry has underpinned many technologies that now routinely contribute to the continued improvement of the quality of our life. The study of chemistry requires much time and patience, since by nature it demands a great deal of accuracy and meticulousness. The importance of chemistry to our survival in this changing world merits the time and effort it takes to study. While studying chemistry, one should always stay focused and motivated, as this will result in less rereads and faster understanding of the concepts. It is very important for students to have a thorough grounding of each topic as they arise, as this forms the foundation for more advanced topics due to the interrelatedness of the concepts that comprise the subject. It cannot be overstressed that many failures in the subject result from weaknesses in the foundation topics. To be successful at studying chemistry, one should review new information daily and engage in constant practice. Chemistry requires a lot of testing, analysis, and reporting. Therefore, a lot of patience is required to become proficient at these skills. Before conducting any form of experiment, it is vital that all instructions be read and understood before proceeding, and the necessary laboratory safety rules be observed at all times, since the opposite can prove disastrous. The syllabus is divided into 3 sections. Section A, Principles of Chemistry. This section covers states of matter, atoms on the periodic table, mole concept, structure and bonding, mixtures and their separations, physical and chemical properties of matter, acids, bases, and salts, oxidation reduction reactions, electrochemistry and rates of reaction, energy and energetics. Section B, Descriptive Chemistry. Organic chemistry. Organic chemistry covers aspects of chemistry that deal with the bonding and properties of carbon compounds and includes introduction to organic chemistry, reactions of carbon compounds, sources of carbon compounds, polymers. Inorganic chemistry. Inorganic chemistry deals with properties of metals, reactivities of metals and their uses, extraction of metals, preparation and collection of nonmetals, uses of metals and nonmetals, conservation of metals, identification of anions and cations, impact of metals and nonmetals on living organisms. Section C, chemistry in the society or home. The topics in this section of the syllabus are offered as a choice for the examination paper each year. A measuring cylinder is used to quantify a volume of liquid where high accuracy is not required. Place the cylinder on a flat and horizontal surface. Pour in the liquid and read a volume that corresponds to the graduation mark in line with the bottom of the meniscus. If a desired volume of liquid is required, add dropwise when near the required graduation mark until bottom of meniscus is in line with it. Interpret the scale correctly. At eye level to avoid parallax. The burette is an instrument used to accurately measure the volume of liquid reagent dispensed in experiments such as titrations. Rinse the burette with the liquid with which it is to be filled. This is called conditioning. Place stand on a flat and horizontal surface. Position burette vertically within the burette stand for proper reading of the meniscus. Fill the burette using a funnel to prevent spilling. The funnel must be removed before taking readings. Bleed the burette by opening the top for short duration to ensure the tip is full of liquid and there are no air spaces. Tap the burette lightly to displace any air bubbles. Adjust the level of the meniscus to just below the 0 graduation mark. Take initial reading by positioning the eye level with the meniscus. For accurate work, the reading should be expressed to 2 decimal places with the second decimal place being estimated. Position fingers and thumb around the top, coming in from behind and run out desired quantity of liquid. Take final reading and determine volume of liquid dispensed by subtracting the initial reading from the final. The pipette is used to accurately dispense a specific aliquot of liquid. It comes in various volumes, the 25 mils, 20 mils, and 10 mils being the most common. A pipette filler is used to safely fill the pipette rather than sucking the solution up using the mouth. There are 3 basic types found in a student lab. A simple rubber bulb, which when released after deflation will inflate, pulling liquid into the pipette. A rubber bulb with 3 valves, one for allowing deflation, another for inflation, and another for dispensation. A cylindrical polycarbonate filler with a wheel that can be turned with the thumb to either pull up or release the liquid. Attach pipette filler securely to pipette. Rinse the pipette with the solution to be used by pulling some up with pipette filler. Filler, again, pull the solution into the pipette to just above the graduation mark. Remove the filler and place the index finger quickly over the pipette to prevent the solution from flowing back out. Rotate the pipette gently against the finger to allow the solution to slowly run from the pipette until the bottom of the meniscus is in line with the graduation mark. Ensure that the eyes are at the level of the graduation mark to avoid parallax errors, and the pipette is vertical during this process. Remove the index finger and allow the solution to drain under gravity into a clean container, removing hanging drops by bringing the tip of the pipette in contact with the inside surface of the container or the surface of the liquid. The remaining liquid, as the pipette is calibrated to precisely dispense the labeled volume of liquid should the steps be followed exactly. The thermometer is used to measure temperature or temperature change or gradient and is usually calibrated in degrees Celsius, degrees Fahrenheit, or in Kelvin. The most commonly used thermometer in schools is the liquid in glass type, which consists of a liquid such as alcohol or mercury. It is stored in a protective casing to prevent breakage as it is made of glass. If a mercury thermometer is accidentally broken, the student should not attempt to clean up the fluid, but should clear the area and notify a lab technician or supervisor as soon as possible. To use the liquid in glass thermometer, first remove it from the protective case and hold upright. Examine the column of liquid to ensure it is continuous. No breaks or bubbles should be evident. If the column of alcohol or mercury is continuous, proceed to use the thermometer as per instructions. If not, ask for another thermometer. Immerse the bulb of the thermometer into the liquid, holding vertically, avoiding contact between the bulb and walls of the container. Allow adequate time for the mercury or alcohol to rise and come to a steady reading. Read at eye level to avoid parallax errors. Remove thermometer and rinse before using it for another reading. Replace the thermometer in its protective case when you are finished using it. A separating funnel has the shape of a cone surmounted by a hemisphere. It has a stopper at the top and a stopcock or tap at the bottom. Typical sizes are between 50 milliliters and 3 liters. The separating funnel must first be cleaned and dried before use. To use the funnel, the mixture to be separated is added through the top with the stopcock at the bottom closed. The funnel is then closed and shaken very strongly to bring the phases into close contact. The funnel is then inverted and the tap carefully opened to release excess vapor pressure. The separating funnel is placed in a clamp and allowed to stand until the immiscible components of the mixture are completely separated. The stopper is removed and the tap then opened, and each layer is allowed to drain off into separate containers. At least 3 clean containers are needed for a 2-fraction separation. One for the lighter fraction, one for the mixture of the 2 fractions at the boundary, and one for the heavier or denser fraction. The Bunsen burner is used in laboratories to provide an open flame primarily to heat substances. In order to use it safely, it is important to know the correct procedure for lighting and adjusting the Bunsen burner. Bunsen burners can produce 3 different types of flames. The safety flame is the coolest. This flame is yellow-orange and burns at approximately 300 degrees Celsius and is never used to heat anything, but shows that the Bunsen burner is lit. The medium flame, also called the blue flame or the invisible flame, is difficult to see in a well-lit room. It is the most commonly used flame and burns at approximately 500 degrees Celsius. The hottest flame is called the roaring blue flame. It is characterized by a light blue triangle in the middle, and it is the only flame of the three which makes a noise. It burns at approximately 700 degrees Celsius. The first step is to ensure safety by removing fire hazards. Lab coat on, long hair tied back, safety glasses on, books and papers away from the flame, apparatus set up not too close to the edge of the table. The second step is to close the air holes on the burner. The holes can be adjusted to let in more or less air by turning the color. Light the Bunsen burner. When you have a flame from the match, turn on the gas tap. Some taps have a safety feature where you must first push down, then turn on the tap to ensure that the taps are not accidentally pushed open. Approach the match to the top of the Bunsen burner and it should light. Adjust the flame by turning the color so that you have the appropriate flame for the experiment, usually the medium blue flame. During the experiment, stay vigilant so that if a problem occurs, you're ready to turn off the flame quickly. This means that you should not leave your table unattended. Test tube holders are racks that are designed to hold test tubes within a laboratory environment. Test tube holders come in a range of sizes, including racks that hold multiple test tubes, as well as a single test tube holder, which allows the person to hold one test tube at a time using a metal clip at the end of a handle. This is used to grip or hold the test tube firmly about halfway up its length, especially during heating or when reacting two chemicals to prevent contact with the hands. The test tube is placed in the holder in a vertical manner, and when substances are added to the test tube, the holder is articulated in a fashion where the mouth of the test tube is held away from the experimenter or anybody around the experimenter. Ensure that the test tube holder is working properly in that it can hold the test tube and its content, and to prevent the test tube from falling and causing accidents. This is a glass rod, typically about 6 to 12 inches long, 1/8 to 1/4 inch in diameter, used to stir substances or to transfer liquid substances from one container to another without spillage. Before using the stirring rod, ensure that it is clean to prevent contamination of the substance. Be careful not to put excess pressure on the rod, as it can easily break. Glass is used because it is an inert substance in that it will not react with most substances. When stirring substances, do not hit the glass rod against the walls of the container. When stirring is completed, be sure to remove hanging drops from the rod into the container. If the same rod is used for multiple stirrings, it must be kept clean between each operation and should not be left lying on the desk.